Alright, so here we are in the chapter review looking at 5 in the section 8.7 part. And let's actually go ahead and start out by doing what the directions say and factor. So you have x plus 4 and x plus 3. Any questions on that? On the bottom, that's the difference of perfect squares, so you have x plus 2 and x minus 2. And in our search for things to cancel, we failed. Nothing matches, so nothing cancels. If nothing cancels, there will be no holes in the graph. Okay, so from 5a, we know that there will be no holes in the graph. Let's talk about b. The one thing that you need to keep in mind when you're factoring, if everybody has an x in them, you take that common x out, then you factor the remaining part that's in the parentheses. We'll do that in the next step. Let's go ahead and factor the bottom while we're here. X plus 1 times x plus 1. So the common x that they had came out, but we still have a factorable trinomial in here. X squared minus 5x minus 14. That's going to be x minus 7 and x plus 2. So again, in our search for a hole in the graph, we came up empty because nothing cancels. Nothing is the same. So in 5b, there will be no holes in the graph. In fact, on the back here, the only one that had any holes in it was 6a should have a hole at 4, 1. 6a should have a hole at 4, 1. Perhaps we'll make another video for that. What we need to talk about now is, how do I know that 5a has a horizontal asymptote while 5b has a slant asymptote? Well, here's the answer. 5a has a horizontal asymptote because the x squared and the x squared are considered to be balanced. When they're balanced like that, meaning it's not top-heavy or bottom-heavy, the asymptote is at y equals the ratio of their leading coefficients. 1x squared over 1x squared. 1 over 1 is 1. So that's why when I go down to 5a on number 7, there's going to be an HA at y equals 1. A horizontal asymptote at y equals 1. They're balanced. So it's the ratio of the coefficients. Moving on to why 5b has a slant asymptote. Well, the top is x cubed while the bottom is x squared. Since it's top heavy and nothing canceled, there's going to be a slant asymptote. That slant asymptote can be found through the magic of long division. So you take the bottom, x squared plus 2x plus 1, and you divide it into the top. X cubed minus 5x squared minus 14x. Not sure how your long division skills are these days, but here's how it works. X squared times what will make x cubed? Distribute it to the divisor. X cubed plus 2x squared plus x. Line minus quantity. X cubed minus x cubed goes away. Negative 5x squared minus 2x squared is negative 7x squared. Negative 14x minus x is negative 15x. If there's nothing to bring down, you could bring down a 0, I suppose, if you feel like having a constant there. Next, we need to look at the leading x squared and the minus 7x squared. You would need to multiply by negative 7 to make negative 7x squared match. Distribute it, minus 14x, minus 7. Put a line under it, subtract the quantity. The 7x squareds cancel. Negative 15x minus 14x, it's actually minus minus, so it's actually negative 1x. plus 7. That remainder, negative 1x plus 7, has a lower degree than the divisor. That means we have a remainder. If your task was to rewrite this function with its remainder, then I would carry that remainder up to the top and put it over the divisor. That's not really what we're interested in. We're just interested in this x minus 7. That portion of the quotient, not including the remainder, is where your slant asymptote is. Your slant asymptote will be at the line y equals x minus 7. We could confirm this by graphing the original equation in 5b in y1. Put this asymptote in y2, and you'll see that the curve does this. And down at x minus 7, if you went down to negative 7, and you graphed that line, it would run right alongside of that curve. That's where that slant asymptote would be in 5b.